For most of you, this is a welcome back. Good morning, afternoon, and evening, everybody. Welcome to Session 3 for the NASA Aquarius Data Training Webinar Series. This is your host, Jennifer Brennan. So it's 2 p.m. Eastern Daylight Savings Time here, and we are going to go ahead and get started. What I'd like to do first is go over some logistics related to this webinar. To ensure best audio experience, the conference has been placed in silent mode. However, if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod located on the lower right-hand side of your screen. This works like a chat. The webinar will be recorded, and I will post it both to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a couple of days of completion. What I've also been doing is posting the direct link. I've been sending an email, and then I've also been posting that to the wiki once that's been completed, as well as the YouTube link being posted to the wiki as well, so that you've got multiple ways to find this information. Okay. All presentation and video files will also be available for download, although today we don't have any video files at the end of the webinar. As far as timing is concerned, this session will be 1 hour and 30 minutes long. We've allocated an hour to presentation and live demonstration, and then the final 30 minutes will be dedicated to an optional question and answer period. After our speakers have finished their presentations today, I will provide some closing information, and from there what we'll do is we'll move to the question and answer period. As a reminder, you will have an opportunity to ask your questions throughout by using the Q&A pod. The only exception for this is during the live demonstration. We want to have the largest amount of real estate for the live demo that we can. So during that period, you won't be able to ask questions, but not to worry, your questions, if you ask them earlier on, they've been captured and will be reviewed at the end. Okay? All right. So today's speakers, Annette DeCharon, who is the NASA Aquarius Science Communications Lead located at the University of Maine, Dr. Vardis Santos, the Lead Data Engineer at NASA's Physical Oceanography Distributed Active Archive Center, and we refer to that data center as the Kodak. Okay, with that, it is my pleasure to turn it over to our first speaker today, Annette DeCharon, who will kick off today's training by going over the session objectives in a little bit more depth, and also to provide a recap for last week's homework. Annette?
Thank you, Jennifer, and welcome everyone. Thanks so much for coming to today's third of 4 webinars. I'm now going to go over the homework, and so the session 2 recap. Jennifer, do you want to load that? Thank you. So I want to thank all of those of you who've completed the homework. We really appreciate your doing that, and it's not too late. If you didn't get a chance to do the session 2 homework over the past week, you can still do it. We are still going to be monitoring the wiki and giving feedback, and so please don't feel like if you missed the deadline that it's over. We really do want to hear from you, and we want to be able to give you feedback. The objectives for the assignment were to create at least one data plot using Kodak salinity data, describe the data and rationale for the plots you chose, and discuss the processes you use to discover, access, and plot your data. And I have the photos of 2 champions out there, Fred Bingham and Jorge Vasquez, who've been really great about commenting on your homeworks, and I'm hoping that you appreciate and really understand how much they are trying to help you understand the Aquarius data. So I want a special thanks to Fred and Jorge. And both of them will be available in the Q&A section of the webinar if you want to hear more from them or ask them specific questions. So I'm going to now go into some of the things that you all have put on the wiki, and I got to say I'm very impressed, as are other folks who've looked at it. Here's an example from one student. She plotted global salinity data using a lot of different projections, including mole-wide and rectangular animations that she made. What was really cool was the types of, some of the projections I had never seen before, and it's always interesting to look at the different kinds. And the software that was used to do this, which is Panoply, which was the homework number 2, it allows you to really look at different projections easily, and so it's kind of fun. Another thing that this student did was plotted the difference in salinity from one time to another. That's this map right here. And also a really cool thing was wind vectors. Plotted that over, I believe that the color bar is also talking about the speed as well. So that was a really neat set of maps that was made by the student. Another one plotted a whole bunch of different kinds, which is really neat to see. Global salinity in what's called a hammer projection. I'd never heard of that. I would have thought that looked like a hammer, but no, it almost looks like more wide. Some Mallu plots from the different ocean basins, and the one here is from the Pacific or the Atlantic, but she also did the Pacific and the Indian Ocean. And this is a time series from the Rio de Plata, the mouth of the Rio de Plata as it goes into the Atlantic. And this one happens to be some wind vectors, again, showing between South America and Africa. Really nice color choice, really a beautiful diagram. And also this student made a Google Earth movie. So that was this examples. This student, and I call you students, and I know I don't know what else to call you, but there it is, did some difference maps and actually chose, I think, monthly average data between subtracting March data from September data and December from July to get these two plots to show sort of differences in between half a year. And also made a really cool movie that's posted on YouTube, time series of animations of monthly salinity zonal means. So how the average across longitude. So that's available on YouTube. And of course, the best place to look at it first is on the wiki because there are some descriptions there as well. This student also made a couple of animations, but started with an annual mean. So over the year 2014 for sea surface salinity data. Made that into a rectangular projection and then used that to calculate anomaly data, and made a movie out of that, which is on YouTube, and then took the data and projected the created a KMZ file and put that into Google Earth. So you can look at that as well. And this, so that was just a overview of the homeworks that were submitted for session 2. I would strongly encourage you to go look at them. There's a lot of great comments. A lot of people were helping each other back and forth and learning from each other, which is basically what we want from this advice webinar series, is for everybody to give each other comments and hints and learn from each other. So, but if you still want to do your homework, please feel free to do it. So that was session 2, and now we're going to go into session 3, which is going to start with a demonstration of Aquarius visualization tools by Dr. Vardis Santos, who's a Kodak data engineer. That will be followed by talk about effective communication techniques, and then we'll have the Q&A as mentioned before, and next week is the virtual poster session, and I will describe that in further detail later on. So Vardis, please take it away. Thanks so much.
Thank you, Annette. This is Vardis from the Kodak, and I'm just going to bring up my web browser right now. Hopefully everyone can see my web browser screen. I'm currently in Google, okay? And so first thing is, how do we get to the Kodak portal? Just Google Kodak. And in fact, we want to go directly to the Aquarius mission page. So just click there. And if you remember from our from the tutorial and material presented in the first week, the one-stop shop for all types of information, technical documentation, and other data resources relating to the Aquarius mission at the Kodak is this Aquarius mission page. Now, on the right-hand side here, you'll see Kodak tools and services, and we covered some of these things like OpenDAP, Threads, Kodak web services for discovering, accessing and subsetting data over the web on the fly, a programmatic approach to doing that. But in addition to those, we also have a series of web-based tools for visualization where you can do these operations through a graphical user interface. So the first tool I'm going to describe is a very simple tool, but nonetheless pretty useful, and it's called the Aquarius Level-3 browser. And all this tool does, it basically provides a visual interface for exploring some of the Level 3 Aquarius datasets, some of the key ones, okay, for salinity in particular. So basically, it's very straightforward. You have a calendar control on the left, and right above it, you have a selector where you basically select the product time interval that you're interested in. Again, these are all salinity Level 3 data sets. So now, right now, we're looking at a Level 3 daily image for June. Okay, we can use this time selector to basically select any date in that month. Okay, and you can see as I do that, the image is updated here. I can click on it to get a larger visual of it. Okay, and further below, what you see is basically like a film strip of all the images in terms of the daily data for that month. Okay, and you can also basically, rather than using the calendar control, you can just directly click on the item in this film strip display. And likewise for the weekly imagery, let me bring those up. You can see the number of images now are for a given year, so you have 4 per month, and in 2015 you had these many images basically. Okay, and now let me basically, you can use this tool as well to run animations for the time period that's currently displayed. So if I click on this little animation control here, you can see it's stepping through sequentially the images, and you can look at the evolution of salinity patterns globally with this tool quite effectively. You can stop at any point, you can step back, you can step forward, etc., etc. Very straightforward, easy tool to use. For just quickly browsing Aquarius Level 3 data, salinity data for a range of time intervals. Again, it's not all time intervals and all data products, it's just some of the key ones. Okay, so this is one of the tools, Level 3 browser, and you're welcome to play with that on your own time. Again, you can access it directly by going to the Aquarius mission page and clicking under Tools and Services, Aquarius Level 3 browser. The second tool that we're going to explore now is called LAS, Live Access Server. It's a tool that is developed by NOAA, okay, and which we host here. It's a widely used tool for displaying earth science data, and we host it here at the Kodak. So when you click on this link, you'll get this page at this point in time. We've actually just recently upgraded our LAS software to a new version, and that's under user acceptance testing. So we encourage you, in fact, when playing around with this tool, if you do come across any issues with this new version, to drop us an email and let us know, because again, this tool, this current version of this tool is under evaluation. So anyway, just before I click on the link, I just wanted to point out that at the bottom there's a link to a series of tutorials, okay, on the usage of this tool. Okay, so if you're new to LAS, you can basically check out some of that documentation, and that will help you become familiar with the tool. But it's very straightforward. Let's go to it right now. Essentially, again, it's a web-based tool. Now, not only for visualization, but it's a tool for subsetting data, so for basically cutting out portions of the data that you're interested in and extracting that data as a data file that you can then work with locally on your machine. And it's a tool for doing some basic visual analysis. So the first step is basically to choose, as you get prompted here, is to choose a data set. And you do that by clicking on this data set button, and what you get is essentially a list of data sets, okay, Aquarius and other data sets that we have at the Kodak, including various sea surface temperature data sets, the Aquarius data sets, etc. And essentially, you just select one data set that you'd like to review. So let me, for the purposes here, let me just pick the Aquarius CAP sea surface salinity data. You could select any, okay? And this is what comes up. Immediately, you get a map coming up with a global map, and it defaults to the start date of the time series. You can control which day of the image you want to display by making selections in these little dialog, time dialog boxes. So let me select another month, and you'll see, okay, nothing has changed, but you'll see at the top right here, you have now update plot button that is red, okay? You can click that, and you see it's spinning its wheels for a minute, and now it's basically run the query on the back end and created a map for the date that you selected. One useful tip here is you'll see this little checkbox, and you want to, in general, you'll want to have that checked all the time. What that means is that basically anytime you do a new selection on the interface, such as picking a new date, it will automatically update the image without you having to manually click the update plot. Okay? So that's a little tip that's useful to know. So a quick orientation now of the user interface. You have the map screen. You have here some information about the query that's been executed to produce this map. You can get rid of that quite simply and maximize the real estate by getting rid of the annotations, okay, or bringing it back. But you see your time controller is still there, so that is not lost. This panel on the right basically allows you to zoom into particular areas of the globe that you want to see an image for. Okay, you want to say, so you can. It's a very straightforward tool. You can basically pan and you can zoom in and zoom out. On the right here, you have some preset areas that you can choose from, and it will automatically zoom into those areas. But let me just pick now sort of the broader Atlantic region here. And you can see automatically, because I have the update plot checked, it's for that date that was selected previously, it automatically zooms into that area and updates that plot. So that's great visually, and you see how fast it actually is as well. Say now I want to, we have the color scale at the top, which tells us what the salinity, what the colors on the map actually represent in terms of salinity values. But we can actually look at the underlying values as well for this subsetted region that we've selected by clicking above here on the toolbar, the Show Values button. Now, there's several things you can actually do in here. You can, in fact, undertake transformations of the values that you can then see those. But let's just do a simple, let's see the raw values from that map. And you see very nicely it produces a tabular matrix essentially showing the data. These dots represent null values, and then the actual salinity values are listed above. So through this method, you can basically not only look at the maps graphically, but look at the underlying data values very effectively. But the next thing that users typically want is to actually download the data for a subsetted region of interest locally onto their machine. So there is a button here, Save As. You click on that, and you'll see you have several options. Now, you have already, in the previous screen, selected the spatial area, the spatial domain of the query. This dialog box allows you to modify the time range for that query. So you can extend it. If you want, you can download the entire time series for that region as necessary, depending on your needs. Just for simplicity here, let me just pick a few days. Yeah, we're looking at a 7-day image. So let me just pick, let me just pick this. And here you can control the output format. For the purposes here, let me just select a CSV file because we can browse that directly within the web browser itself. So let me just select that and click Save. And what you see here, because this is a CSV file, okay, it actually comes up in the browser window itself. And so you see the times and the latitude and longitudes for that area that we were previously looking at with the associated salinity values. You'll notice this minus 1 to the power of 34. This basically is a null value, and so when you actually work with these data, you can save this directly, right? You can go File, Save Page As, and you can basically download this data as a CSV file. Basically, when you do your analysis, you want to treat these values as null and not include them in any analysis in terms of computations that you may be doing. Okay, so that's and again, you can output it as a netcdf file, which you can then work with in Panoply or any other environment such as MATLAB or whatever to do your detailed analysis. So that's the fundamentals of basically subsetting data and inspecting the values and downloading, extracting the values to your machine. One of the nice features of this tool is that it supports it supports graphical analysis of data as well, okay, over the web. So you'll see here right now we're displaying one plot, but there's an option to actually display a panel of up to 4 plots. And so what you see immediately is that it remembers the subsetting region that we were dealing with, and it's brought up the exact equivalent image. But what I can do is I can select for that particular panel here a different date, and you'll see it updates. Let me just see, it does the query. And so you can do visual side-by-side comparisons of the same data set on different dates, or you could select a different variable that's in the data file. In this case, these level 3 data files only have a limited number of variables, some of which are not particularly useful, but let me just for the sake of argument do it. And this is the data that's contained in that file. So you can do a comparison variable by variable, but you can totally change which data set you're looking at. I could pick an SST data set. Let me pick wind speed, again, from Aquarius. Close. And so again, for the same time period that I've selected, for the same spatial domain, I can look at a totally different data set and compare values. So this is a very powerful tool, and you can do up to 4 of these panels at any one time. So this paneling feature applies not only to these maps, but to other types of plots that LAS supports. So let me just show you some of these other plot types. It's kind of equivalent to what you guys were doing last week in Panoply. The difference is that this is web-based. These queries are executed on the fly, okay, and there's no downloading of data necessarily involved. So let me do a simple time series plot now. Let's select a region, okay. With this little control here, I can go to any part of the globe, select a point, and for that spatial area, that spatial location, okay, it will compute a time series of sea surface salinity, because that's what I have selected, for that location, okay? And the nice thing is that you can do, just like we did comparisons before for the maps, you can do comparisons as well for other regions. So let me compare the Pacific with the North Atlantic for the same time series. Okay, so you can see how salinity varies at different locations over time. And the nice little thing with this time series capability is you can click on this difference mode button, and what that will do is it will update the plot further to the right. What it has done is taken the initial blue plot that was here and subtracted it from this other time series plot for that other region we had selected, and it plots a time series of differences. So again, you can see how this tool can be used quite effectively to do some basic visual analysis of data. Okay, let me go back to the one plot. So other plots you can do, again, you can do these line plots not only for time series, but you can do them for spatial transects. So I can draw a transect across the Pacific, longitudinally, and get basically an XY plot of salinity versus longitude, and how that varies across the Pacific. I can do something exactly equivalent in terms of latitude, okay? And so it works in the same way. Now, another type of plot that is supported by LAS is Hofmüller plots, and you were exposed to those last week. And what these are kind of a combination. Yeah, let me select a slightly smaller area here, going across the Pacific. Again, you can basically draw any interactively, and it does the queries and updates the plot on the fly and very quickly, as you can see. So what Hofmüller plots are kind of like time series plots, but in a spatial context. And what you can see here is just like you had oscillations and periodicities evident in those time series plots that we looked at a few minutes ago. You can see those types of temporal variations in salinity. Oops, excuse me. So we're back. So you can see those periodic oscillations, but in a spatial context and how they vary with longitude. And what you can see is that the further the further you get to the date line, basically the middle of the Pacific, the less variable salinity is, okay, at that line of latitude over the time series. Whereas as you get further towards near shore, okay, you see much more variability seasonally, etc. So you can see these periodic structures through these Hofmüller plots. You can also see potentially through Hofmüller plots wave-like propagations in salinity. If you see somewhat of some structures in color that seem to progress diagonally across the image, that is suggestive of some kind of periodic organization to the salinity values along that longitudinal line. So this is how you can use these types of Hofmüller plots to, again, do some more careful visual analysis visually through a tool like LAS. And I don't know how I'm doing for time. I think I'm pretty much at the end of my allocated spot. But I think this pretty much covers the full range of functionality of LAS. Just one other thing to mention very briefly is that you can, if you're interested in sharing these displays that you have generated with a colleague or a friend, you can basically click on this link button, and you can basically just send that to them. If they copy and paste that into a browser, they will be able to replicate the exact screen view that you have here. So in this way, you can use this capability to work collaboratively within a team, okay, by sharing links. You can also select to print, and if you right-click and say Save Image As, you'll be able to save this image as a GIF file for use in a report or publication. And with that, I think that concludes really, most of the functionality of this tool. As you can see, it's pretty intuitive to use. So I encourage you to give it a try and let us know how you get on. Thank you.
Okay, we're going to now transition back to Annette de Charon.
Thank you, Vardis, for that nice overview of the LAS. So now we're going to get to my part. I'll introduce myself again. This is Annette de Charon, And this part of the webinar is about how to effectively communicate your salinity story. So, in the past, and I found this, I was really kind of excited to find that this is the press kit from the Apollo 11 moon landing. If you put in the right search terms in Google, you can find this. But back in the early days of NASA, science journalism was the main conduit for dissemination of scientific information to the public. Basically, you had to go through these guys with the headphones, and it was a very well-orchestrated and formal process for people to share their science. Nowadays, the transition from traditional to social media has had a big impact. On the right there, you see a recent screen grab from the NASA homepage, and researchers now have more opportunities to directly share their work with the public. There are podcasts, there are webinars, there are lots of ways to do that, and so therefore, not just the skilled communicators talk to the public about science. All of us can and should talk to the public about our science. And so one of the things that is, if you're talking about the past, one of the sort of the old ways of doing things was called the information deficit or knowledge deficit model. And that was the thinking that communication is a process of transmission. The facts speak for themselves and are interpreted by all citizens in similar ways. And if people don't accept or recognize the facts, then it's their fault. They've actually done studies on this, surveys, where they polled scientists from all over the world asking about what's the problem, why do people not understand science or appreciate it, and unfortunately a very high number of U.S. scientists basically blamed the public for not listening carefully and not understanding even though they had communicated clearly. And so I have here, does this approach sound familiar? And I ask this because I think, we've all gone to college and we've all probably had a professor or two who basically, if the information wasn't interpreted correctly, it was always the student's fault. And so that's kind of the old school information deficit or knowledge deficit model. But understanding what motivates people to learn is more important than your intuition. Even though you think you've said something super clearly, it really is more important to know about the type of audience you're talking to and what their preconceived notions are or what their feelings are about the topic. What I have here are data from Yale George Mason University, and they did a long-term study asking people about global warming. And so from the questions that they asked, they ended up binning people into certain areas. They had people who were alarmed, and that's the left-hand end of the spectrum. And at that point, there was 16% of the people were classified as alarmed. On the other end of the spectrum, the right-hand side, they had people who were dismissive. 13% basically had the lowest belief in global warming, least motivated to do anything about it. And so you had this whole spectrum of people. And in the middle, you had people toward the left who were concerned but not alarmed. And then you had people who were doubtful, but they were willing to listen, but they were doubtful that climate change was happening or global warming. And you had all these people in the middle, the cautious or disengaged. And if you're thinking about how to communicate people or whom to communicate to, some people would suggest, and I might be one of them, that, well, with the alarmed people, if they're already alarmed about it, you probably don't need to talk to them anymore. And if they're just going to completely blow you off at the other end, why bother? So the sweet spot's in the middle. Those are the people that you might have a positive impact with. This slide, it's a little hard to read, but so understanding what motivates people to learn is more important than intuition. And so one of the things that they did in this study is they asked people, if you could ask a climate scientist one question, what would it be? And so this graph, which is the important part of this slide at the bottom, is basically the types of questions that they want to ask a scientist is very highly dependent on their beliefs. So if they're alarmed, if they're in the alarm category, they're going to ask a scientist, what can I do? What is the action I can take? If they're dismissive of global warming, they'll say, well, give me evidence. I want to know why tell me why you think this is the truth. And so this graph is basically talking about the types of responses you can have to people, the types of things you can talk about with people, depends on what their interests are. So they might really want to hear actions. They might demand evidence, or they might be somewhere in the middle. They might want to know, well, if this is really happening, what are the consequences? Or, I don't know what the real causes are. Can you explain that more to me? So this graph is basically based on data from lots and lots of people, and what you talk about with people depends more on their interests than what you want to say to them. So we've talked about communication. So there are tips and tricks for communicating with the public, and NASA Communications is basically aimed at the public. Almost everything they do is aimed at the general public. And what does NASA recommend? So they recommend that you should have a specific take-home message. When you interact with people, if you're going to have, give a talk at a library, even if you're going to sit on a plane next to somebody, maybe that's not as important on the plane, but if you're going to go give a talk, you need to have something that people can walk away with and say, that's what they were trying to tell me, that's what I learned. And it should be specific. You can't tell them a whole bunch of things and hope that the thing that you wanted just pops out, okay? So you should really think about the things you want either a viewer or reader of your story to come away remembering. And it's easier, of course, to remember things that are simple and short. Another thing that NASA recommends is take out all of the jargon, all the insider words that you and your colleagues are very familiar with but is not probably really known by the public. And avoid using acronyms if you can. I mean, you could use NASA because everyone knows what NASA is, but most acronyms are just unknown to people. And you should use a language and comprehension level that the public will understand. And so you might be asking yourself, well, what is that language level? Well, that's what we're going to talk about. In poll number 1, so you will next be prompted to answer a poll question about NASA's guideline on the language level to use with the public. So there is an answer. They do have a grade level. And so the poll that you're about to take, and you'll get 30 seconds to fill it out, will give you some options, and we'll see how you do on that. So Jennifer, if you could do that would be great. So go ahead and take the poll. What is the language level that NASA recommends using with the public? 6th grade, 8th grade, 10th grade, or 12th grade? Okay, it looks like I think people are done. So Jennifer, can you broadcast the results so people can see now? And so there's a lot of, there's a lot of answers in all the categories, so there's no definitive answer here. However, we're kind of going towards 8th grade being the answer that most people chose. And Jennifer, would you mind revealing? And that is correct. 8th grade, 13 to 14 years of age, is the language level that NASA recommends using with the public. You might ask yourself, well, why is this? Well, if you went to the school in the U.S., you might remember that the last time you were required to take a science class was probably in the 8th grade. If you didn't go on to major in science, you were probably allowed to not take any or very few science classes after that. And also middle school, which is 8th grade in the U.S., is where they have the integrated science, where it's not just I'm going to take physics and that's it. It's where they have the more holistic look at sciences. So that is the grade level that is recommended by NASA. So next we're going to have another poll. So this poll is basically, so you're asking, well, how do I know if something's at an 8th grade level? Well, there's actually tools in which you can figure out how to do that. And there is one called, I have it on my slide here. I can't remember it. It's called readabilityscore.com. I apologize for that. And so what I did was I had a bunch of graduate students that I was doing a workshop with, and I asked them to try and write a statement about their own research at the 8th grade level. And here's a sample of the statements that they made. Only one of these statements was close to an 8th grade level. And so I'm hoping that you guys can pick which of these statements that were written by graduate students is written at about the 8th grade level. So we're going to go ahead and vote for that. I'll give you a few minutes because there's more to read than the previous option. Again, we're trying to identify which of these statements that was evaluated on readabilityscore.com got to about an 8th grade level. And I will explain the rubric or the algorithm used after we're done. Okay, if you want to spend a few more minutes, or a few more seconds, I guess. Okay, why don't we go ahead and broadcast the results, Jennifer? Thank you. So here we go. So the statement that got the most votes is there is a balance needed between human energy needs and environmental health, was the statement that folks got the most votes for being at an 8th grade level. So Jennifer, if you could go ahead and put the slide on. This is the actual scores produced by readabilityscore.com. Those are in the brackets. So the first one, in Lakes, things change fast, so you have to keep an eye on it, is actually only a 3rd grade level. The second one, which got the most votes, is there is a balance needed between human energy needs and environmental health, got a score of a grade level 11.5. The next one, new satellite technologies can help us explore where different types of microscopic life are found in the ocean, was graded at 13.2. And the next one was the answer, the closest to 8th grade. We need to understand how tidal power affects the environment before we can use it. That comes in at a 9.4. The last one, ocean acidification could make it harder for clam harvesters to make money, is at grade level 10.8. So thank you, Jennifer. If we could go on to the next slide. So the next slide talks about the tool that was used to do these grade level analyses, readabilityscore.com. So how it does that grading is based on completely on the number of characters, the number of syllables, the number of words, the characters per word, the syllables per word, and words per sentence. And you might think, well, that's not fair. I mean, some long words with lots of syllables are understood by everyone, and some aren't. Because it's kind of it's a free tool, and it does have that. That is one of the things that is sort of the downfall of it. But it really is. If you think about it, if you're learning something, if somebody's telling you a sentence and it has words that are longer and you might not know them, you need time to process multi-syllable words. Okay, you need to have a moment to have that word seep into your head before you can move on to hear more. And stringing together words with lots of syllables has just been shown to be harder for people to understand. So this is a simple way that you can go ahead and try and just, space apart your more complex words from the easier ones in order to make your message easier to understand. The reason I'm bringing this up is that one of the options for this homework is to create a take-home message and using readabilityscore.com to analyze it and then posting what the grade level is. And I'll tell you, you'll probably have to try it out a few times. The first thing that you come up with for your take-home message probably will be too high level, and you'll have to do a little tweaking of it to get it right. But it's a very interesting tool. I first ran into this because I turned in a paper to be published in Oceanography magazine, and one of the reviewers ran my entire paper through this analyzer. And so, it is used by people when you say you're going to talk at a certain level, people will call you on it, and they'll use these kinds of tools to judge your work. So, in addition to the grade level, another thing, there's some more things that NASA Communications recommends about take-home messages. They should be personal to the audience. They should be something that the audience would care about. And how do you know what people care about? Well, one of the things would be current events. What's happening in the world that people care about. It's good to stay abreast of current events. and that's a way to tie to what people are learning and want to know. And so how do you assess how much people care or know about what you do, about your research? Well, the simplest answer is go ahead and ask them. And so one of the other options for this week's homework is using a free online survey software called SurveyMonkey.com to gather data from people, your friends and family, on some of about your research and some of the terms you use. Again, I'm going to show you some examples used with graduate students for an online course I teach called Broaden the Impacts of Your Research, and I think they'll be enlightening. So one student did one of these surveys and asked the question of her friends and family, how much do you know about estuarine oceanography? And how much do you care about estuarine oceanography? And 61% said they didn't know much about it, and 30% said they didn't really care, they didn't care too much about it, they cared not much. And so this student thought, well, the reason they don't care is because they don't know about it, and so kind of leapt to that conclusion that knowing and caring are related. Another student in this course happened to be do a medical research graduate student, and her question to her friends and family was, how much do you know about innate immunity, and how much do you care about innate immunity? So over 50% said they didn't know much about it, but 40% said they cared about it a lot. They went to the highest level of care, and the reason was, and they wrote in their comments, well, I don't know what it is, but it sounds like it could hurt me. It sounds like it's dangerous, and I don't want it to happen to me. So again, they're pretty much, even though they don't know what it is, because it sounded medical and scary, they cared about it. So these students also, we asked them to take quantitative data with their surveys, talking about terminology and jargon used in their disciplines. And we scored them. They got a term that had been heard by their audience and they knew what it meant, got a 6. If the people on the receiving end of the survey had heard the term but weren't sure what it meant, it got a 4. If they'd heard the term and didn't know what it meant, it got a 2. And the terms got a 0 if people had not heard them before. And so terms with average scores above 5 basically were recognizable and understood by the students' friends and family. So the next poll is going to give you some options, and I'm going to ask you to figure out which of the terms averaged below 5. All the other terms on this list were above 5, so they were understandable and widely known. Only one of the terms on this list of the poll was below a 5. So I'm going to go ahead and ask Jennifer to open the poll and for you to vote on the least understood of these terms. So they are pathogen, immunocompromised, estuary, seasonality, and muscular dystrophy. And these were taken from several students' polls. We just went for the ones that averaged below, we want the ones on here averaged above 5 and one of them averaged below 5. So we'll give you a few more seconds to choose the least understood of these terms. Okay, Jennifer, if you want to go ahead and broadcast the results. So if you guys can see that, the two terms that got the highest votes for being the least understandable were immunocompromised and estuary. So Jennifer, why don't you go ahead and pick the one that was least understood? And the answer is seasonality. Every time I've done this poll, share these results, seasonality always gets the least amount, and I always do it with ocean scientists, seasonality always gets the least amount of votes, but it is actually the one that most people don't understand. They know what the word season means, and they know what the word seasonal means, but the word seasonality is odd. It's a strange word, and you have the definition below. It's a characteristic of a time series in which the data experiences regular and predictable changes that recur every calendar year. But regular people don't know what that word means. So So that's something, maybe a lesson learned. And so, Jennifer, can we have the next slide? So it would be my last slide. So thank you. What did the graduate students learn from this exercise? Well, they learned that the relationship between knowing something and caring about something is uneven and may be discipline dependent. If people hear medical terms, they care because it means something to them personally. And it's not always easy to predict which scientific terms people understand. Seasonality was the lowest score of all the ones that you picked. The other terms are probably known from medical shows and that kind of thing. But, sometimes we ourselves don't know what terms people don't know. So conducting this type of survey is one of the options for this week's homework. If you choose to do this, and of course it's going to take longer than the previous option, the readabilityscore.com, but I think you'll learn a lot if you do it, and you'll be able probably to get results very quickly if you use social media to get people to take your survey. So that's the end of this talk about communication. I hope that it was very quick, but I hope you learned something, and I hope that you'll be able to use these tools in your work to help you hone your own take-home message. So I think we're going to move along to the next part of our session today, which is a preview of this week's homework. I've just sort of given you a little bit of that, and also how we're going to do next week's poster session. So here we go. I've shown this slide before, and I think most of you have been here before, so I'm not going to go through it again. But session
too. The pictures that you saw earlier, those are actually, the first one was an Earth Day event at Union Station last year. That's currently going on right now. I was down there this morning and then all day tomorrow. And then the second photo, I think, was an aerial view of Earth Day at the National Mall. To the left, you would have seen all of the tents. And then the final one was an Explore at Goddard Day. Each year we have well, not each year, it's every few years, I guess, an open house at Goddard Space Flight Center. And so that was an example of, the general public interacting with some of our scientists and various projects here at Goddard. Well, I will give it one more minute. If there are not any questions, what we'll do is we'll log off from the telecon, right? And then I will leave the virtual meeting space opened so that you can download files. And certainly if you think of something, you could also type it into the Q&A pod during that time period as well. So Annette or Carla or Fred or Jorge or any of the presenters, do you have anything to add to this or any comments or anything you'd like to share at this point?
Yes, this is Vardis. One point that I just wanted to make that I didn't make during my demo of LAS is that LAS actually on the back end taps into the Threads service that we discussed last week. So essentially, the back end, the querying engine for everything that you see, all the capability that LAS presents to you through a graphical user interface is actually Threads and also Opened. So the point being that you could write your own visualization client in whatever tool or environment is of interest to you, and create these types of visualization capabilities that may be more custom to your specific analysis needs. So on the back end of LAS is Threads, and so these web services are a powerful way of querying data across the web on the fly. That's the only point I wanted to add to my presentation.
Jennifer, can you hear me?
I can.
This is Fred.
Hi, Fred.
Hi. I just wanted to add one thing to Vardis's presentation. They have this wonderful tool on there, which I don't think he told us about. I'm not sure why. It's called Kodak Drives. So if you want to just download these files yourself and work on them yourself, there's you can basically mount the Kodak disk right directly onto your desktop and just get the files you want and need just by a simple copy operation.
Yeah, Kodak Drive is available, and I didn't mention it because it's still under evaluation. So that will be operational in due course. But yes, people are welcome to go to the user acceptance testing portion of the Kodak portal and play with Kodak Drive. Last week, Fred, I presented a range of other methods by which users can download and access data. For the global files, you can use FTP, and if you need subsets of those global files spatially and time series as well, you can use things like OpenDAP and Threads. And if you want to do that graphically, you can use LAS, like I demonstrated today.
Okay, thank you, Vardis. It does not look like we have any questions for this particular session. Certainly,
actually, I have a question for Fred and Jorge. They did such a great job of commenting on specific individual questions and items that were posted to the wiki. I was just wondering if either one of them wanted to comment overall on how this is the first interaction. I think this is Jorge's first interaction with a wiki like this, and it might be Fred's. I just was wondering if either of you had any comments on how you felt that worked, or if just in general overall.
It seemed to me to work fine. This is Jorge. And by the way, I was extremely impressed with all of the responses. I guess the only little hiccup seemed to be, but the students seemed to solve it, was the animation issue. Being able to put animations on the wiki, but that seemed to be solved. I'd also like to say I was extremely impressed. I think Fred mentioned, everybody was really picked out the seasonal cycle in the different places in the world's oceans. I was also impressed that I think one individual even saw the stripiness in the data. So everybody did, I think, a fantastic job.
Yeah, I would totally agree. The thing that that this whole exercise, well, first to comment on the animations, it would be nice if there was some way, because the students posted these animations on YouTube, which is great, but it'd be nice, the screen that I was looking at, I wasn't able to enlarge, for some reason, the YouTube animation, so it was just in a little teeny square in the middle of my screen. And it would also be nice to be able to loop some of those animations, because the students made some really nice, there was especially one with the seasonal cycle and the anomalies from the seasonal cycle. That was great, that one. But it was, again, it was in YouTube and it was really small. It'd be nice to be able to just to loop those animations. I don't know if YouTube can do that. I doubt it's true. I doubt they can do that. But yeah, and the other thing that really impressed me was, and I'm kind of working on some of this in my own research, is how interannually, the interannual part of the salinity signal is not really that big. From year to year, the changes are not that large. The big changes, as many of the students really figured out, is the seasonal cycle. So that the largest component of variability in the salinity field is seasonal, and in particular in the tropics, between maybe about 20 north and 20 south. The seasonal cycle is really large. So that was really interesting, and the students, a lot of them kind of figured that out.
So Fred, this is Jennifer. One comment I have regarding the viewing the animations on the wiki. The problem with pasting the URL is that it will automatically translate to that widget, if you will, within the Confluence wiki, right? And so what I did for linking, I actually just entered the YouTube URL so that people could, essentially I'm taking them off the wiki to view the sessions, but that was the only way, I agree with you, to get around that. And then the second point would be, I think there is a capability to loop video, and I say that as an owner of our NASA Earthdata YouTube channel. It seems to me within Video Manager there might be a way to do that. So, and I guess this gets to a question as to whether or not, Annette, Carla, and really more so the question is for the students, whether or not you might be interested in having your work posted within the framework of our, the list that I've created for this training series on our YouTube channel. And perhaps you might feel more comfortable just leaving it on the wiki, but certainly if you would like to share that, then that's something that we could put up there. I don't know, what are your thoughts on that, Carla? And then I guess, for the students that are still online, you could type into the Q&A pod how you feel about it. What do you, Carla and Annette, what do you think about this? Fred, Jorge Vardas.
This is Annette. I think that would be a potentially good idea. That's something that we are going to come up with a post advice survey, maybe administer at the end of next week or in an email after the whole series is over. But that's the kind of question we could ask people if they feel like that's a good idea, if they would use or visit a YouTube channel like that. And so I think that's something that we can put to the participants and see if they're interested and include that in the survey. And I don't know if anybody else has any thoughts on that.
Well, I'm not seeing any kind of questions or input from participants here in the Q&A pod. So if there are no further comments and no questions for today, I think what we'll do is we'll go ahead and log off from the telecon, and then I'll leave the virtual meeting space open for those of you who might be interested in downloading the files. And I should mention to everybody that it's unlikely you'll receive a direct link for today's session tomorrow, just because I will be working. Tomorrow is official Earth Day. I'll be at Union Station all day. So I'll try to get that out, if not, tomorrow night, at least a direct link, but it probably won't be posted to YouTube until this weekend, at which point, I'll log on to the wiki and provide a URL and also follow up with an email. But trying to do both just so I can catch everybody in one way or another. Well, thanks everybody for participating today, and we look forward to seeing you again online next week. And you'll be expecting an email from me regarding the poster series, the poster session for next week. And I think that's it for me anyway. Anybody else?
Well, thanks, Jennifer.
Thank you very much. Let's go ahead and wrap up today's session. Thank you for your participation, and we will see you again next week. All right, bye-bye, everybody.